which takes long and string as the input, and it gives the string and long as the output. So you can recall the previous presentation, and the reduce will take the output of map function, that is a string and long, and it will be converted into string long. The meaning of this is the data comes as a stream of strings, and each string will be verified with the number of entities available, or in the split files available. Map function will be applied to verify each and every word available in the split file, and for that a value will be given, and that value, such values will be taken into keyword as well as value pair, and such values will be sent to reduce function. The reduce function will combine them, count them, sum them, and they will create from the string long to string long. That is the meaning of that. So here is the key value and here is the number, and that will be counted and summed up, and final result will be generated like this. So the operation performed by the map function is a simple text extraction. Remember, we are analyzing weblogs. The Aneka logs will be taken for this purpose. So map function is a very simple text extraction that identifies the level of logging and the name of the component entering the information in the log. So this will be done by map function. Once this information is extracted, key value pair, so string long will be generated, is emitted by the function. So this is what you are understanding here. The long string will be taken to string long fashion, emitted. Since we decide to combine two map produce jobs into one single job, each map task will at most emit two key value pairs. So it depends on the implementation how a map task is given to a particular map task executor. So multiple results will be taken and it will be generated, and those values will be combined together to get a single file. So you please understand, in the figure which we have discussed in the previous sessions, the intermediate files will be generated by the map or reduced task implementer, and that intermediate file will be merged together at the later stage. This is because some of the log lines do not record the name of the component that entered in the byte. These lines only key value corresponding to the log level will be emitted. It depends on a particular log file, how the log file is generated. If you look at Unix log files, everywhere you will have the command which has been executed will be there. The program which has been called will be there. The user who has will be there. From which IP address the people are trying to access will be there. So depending on your log files, you can control or you can customize your map designer. The map method simply locates the position of the log level label into the line, extracts it, and emits a corresponding key value. And normally it is 111 will be entered for everyone, and then it will be merged together to have more number. For the same label, suppose you have multiple values, then all those labels will be counted together and you will have one single value for that label. It then tries to locate the position of the name of the Aneka component that entered the log line by looking for a sequence of character that is limited to a column. Okay. If such a sequence does not contain spaces, and then represent the same name of Aneka component. In this case, another key value pair component name one is emitted as we are discussing, because we are giving different types of examples, how the log files are generated and how log files are handled. You can understand this. So the log level labels from component names is underscore is prefixed to the name of the. So it is a standard nomenclature. It's a convention which has been used in the Aneka log files. So next, reducer design implementation. So how once a mapper reads each key value and then correspondingly it will generate a value for that, the key as well as the value. So once it recognizes a key, for that it will generate a value. So that will need to be sent to reducer. The implementation of the reduce function is even more straightforward. The only operation that need to be performed is to add all the values that are associated with the same key. So key will be generated, comma 1 will be there. So key I, no, ki maybe you can consider ki. So many keys will be there. So that will be summed up. You will have one single pair, which is a key value pair for the total sum. So if these values are available in different segmentation files, then those also need to be merged together to get a single value. So you can understand there is a reducer function, reducer program, which is being executed in the client machine also. If you look at the picture available, you will understand that. Okay. So in the MapReduce implementation for a log file, please refer to page number 8.21, figure 8.7, which we have discussed in our case also. Reducer is there, mapper is there for the client machine also. Please understand that. The infrastructure will already aggregate all the values that have been emitted for a given key. Therefore, you simply need to iterate over a collection of values and sum them up. So you are easily understanding all files need to be collected, and then you need to generate a single value for a key. The operation to perform is very simple. Actually, is the same for both of two different key value pairs extracted from the log lines. It will be the responsibility of the driver program to differentiate among the different types of information assembled in the output file. So please understand, it's a very simple program which we are trying to execute. Maybe depending on the data set, we can customize our program so that how the file, because we need to analyze the log files, how the log files are generated. Based on that, we need to generate a mapper function as well as the. Once you develop a mapper function, actually developing mapper function is little complex than a reducer function. Reducer function is only to count the number of values, that's all. Key is there, a value is there. So reducer is very straightforward function, but mapper need to be configured on the or developed based on the log file or a log, not only log file, any type of file, a stream of data which is coming as the data that need to be combined, that need to be analyzed for key values, as well as correspondingly the value 1 need to be appended to that. So that is the key value pair. Once a mapper function is developed properly, and the reducer is only to some of the values. Okay, so next is the driver program which we need to look at. Log parsing mapper. See, if you look at Java implementation, you have a wrapper class in Java. Okay, for example, reading, because Java reads values in a stream fashion. All, whether it is integer, float, string, character, whatever may be, it is considered as a character stream only. So once you read those data, you need to read that as parse int. Okay, you have function there. Okay, parse float is there. So the data from the keyboard, you need to read the data and store the data into the corresponding integer type or a float type or a double type, whatever the type you define in Java program. Similarly, here also a wrapper class will be there to read the data. So you can understand that log parsing mapper, log parsing reducer, these two will do the job of MapReduce. So log parsing mapper and log parsing reducer constitute the core functionality of the MapReduce job, which only requires to be properly configured in the main program in order to process and produce text files. Text files Okay. Moreover, since we have designed the mapper component to extract two different types of information, another task that is performed in the driver application is the separation of these two statistics into two different files. Because in this program, in the program which has been discussed in the text, they have taken two different types of extraction, but these need to be written in a different file. That is there you need to understand. So driver program will do this job. Okay. So please understand, when you do map and reduce for a large set of data, what do you do actually? You do some analysis of that. Similarly, like we have taken example of a big bazaar or Flipkart or Amazon. Every day, lot of transactions are going on. So all these transaction records can be taken as a log, and you can apply map reduce function for those data, and you can analyze how many people have gone for a particular item purchase. You know how many how many items are left out, because you have the inventory also with you, so you can compare the inventory with the output of map reduce function, so that you can understand that which item need to be procured more, which item need not be procured, how is the purchase capacity of a person. All that you can analyze, and you can do. So these type of analysis, you need to have a proper statistics. So to generate a statistic from the given log file, map reduce functions are used, and not only for word extractor or log file generator. Even you can go with a Facebook or a Twitter or any Instagram data of a particular person or a particular users of a particular area, and you can analyze it. Using such analysis, the whole scenario of a particular country also can change, because you already know that data analysis is the biggest task in getting the feelings of a particular section of people. Okay, you understand that. Okay, so that's why map reduce function is very, very important. Wherever you try to use that, you understand the intricacy of a map reduce function, and then to try to use them and get the extraction of the data and do some analysis. So here, from now onwards, we have certain implementations. These implementations are just a skeleton of the program, not exactly the complete program written here. Aneka platform has been used here, and they have shown the program which gives the output of a mapper function as well as a reducer function. Okay. So the class log parsing mapper, it is extended by mapper KV, and provides an implementation of the map function for parsing the Aneka container log files. This mapper emits the key value log level as well as the 1. 1 is actually in the beginning it is 1. Later, once it is reduced, you will have the output of total number of values you got it. See, whenever we think about a reduce, people think that the data will be reduced. Yes, data will be reduced, but it will be summed up and to get the actual value for the log level. Okay, potentially another key value, Aneka component name, if it is able to extract such information from the input. So since this program is taken for two different, one is a log level, another one is component name for the Aneka log only, particularly for Aneka log. If you are taking any other type of log, you need to analyze the log file, and then you need to reconfigure this same program and execute them. So normally we execute with .NET platform as well as Java platform for executing map reduce functions. Okay, so here is a program which reads, first we extract the log level name information since the date is reported in the standard format, and it is possible to skip the first 30 characters. See, this is what the condition here. Why he is skipping 20 characters plus 1 space? Because it is in your log file, exactly you have a particular standard. Maybe if you are analyzing a JPEG file, you are analyzing a MP3 file, or you are analyzing MP4 file, you have a standard data in the beginning, and then actual data will be there. So you can think of there is a key values, key entries, and identification data, and later actual information or image information or video information will be there. So you need to know the exact size of data, exact style of data, exact value location of data, from where you need to access them. Okay, so that's why it is written here 21 star. So you are seeking the value which is at the 21st character, and then you are getting the key value. So you are substring, you are applying substring, start with the stop, and then the key value will be generated. So once it is there, key value and quantity is emitted. So you are sending that. So emit function may write this information in another file, which is maybe an intermediate file which is created from the executor, because multiple executors will be there. These executors will be fed with the split files, and the emit function will generate the output of that. Similarly, if it is a component, then he has got some idea that stop plus 3 is there, so it is generating the component value. So in the beginning it is a log level value, and the same line maybe you have character component value. So with the character mentioning with the colon. So up to that colon it is going, and then it is extracting the data. So it is similar to your Java implementation. You can go through that Java programming and you can understand this better. Okay, this is about a mapper and log parse reducer now. So log parsing reducer, what it does, it will simply count the value. You can easily understand here. Class log parsing reducer extends reducer KV and provides an implementation of the reducer function for parsing the Aneka container log files. The reducer method iterates all over values of the enumerator and sums the value before emitting the sum to the output file. Look at it here. He is going to go to the next word, next word, next word. So move next, and value equal to input.current and sum plus equal to value. So here sum equal to sum plus value is doing. Currently in the beginning value will be 1. So 1 plus 1 plus 1 plus 1 will be done for all the similar values or identical values, and finally the sum will be emitted. You can easily understand these programs from the listing in your regular textbook also. You can go through once again. If you have any queries, you can discuss with me later. The configuration of the job is performed in the initialize method. The method reads the configuration file from the local file. 1 minute. Yeah. The method reads the configuration from the local file system and ensures that the input and output formats are a file or set to text. MapReduce jobs can be configured by using a specific section of configuration file MapReduce. It's only for configuration, and then anyway you have understood what is the output of these programs. Okay, you need to configure MapReduce job. You need to do some post processing of the result file, and you need to do management of errors. Maybe you have some problems in the log file generation. Maybe when you are reading, you may not get a correct format, so you need to worry about such errors, and you need to redo, regenerate. Maybe when the file is sent to the distributed system where MapReduce functions are executed, you need to go through that, and then only output can be generated, proper output can be generated. So format string defines the format of the input file. The property is set. The only supported value is text. Filter string defines the search pattern to be read to filter the input files to process in the workspace directory. This property only applies to the output properties group. New line is again another function which defines a sequence of characters that is used to detect a new line in the text string. This value is meaningful when the input output format is set to text and the default value is selected from the execution environment is not set. Separator is another program. The function, the property, this property is only present in the output section and defines the character that needs to be used to separate the key from the value in the output file. As the previous property, this value is meaningful when the input or output format is set to text. Next is running the application. How do we run the application? So Aneka produces a considerable amount of logging information. You know it because it's a cloud platform. It does a lot of job. That Aneka generates a log file, and log file can be in the form of megabytes or gigabytes or terabytes, and those files can be taken for analysis. The default configuration of the logging infrastructure creates a new log file for each activation of the container process as soon as the dimension of the log file goes beyond 10 MB. So for every 10 MB, it is generating a new file. It's very easy to know. You do not segregate the large file into pieces, so you can put a 10 MB file into one executor, because you have seen multiple executors are connected, and there is a scheduler does the job of scheduling your MapReduce execution. So every 10 MB file can be sent to one executor. Therefore, by simply continuing to run an Aneka cloud for a few days, it is quite easy to collect enough data to mine for our program, the program which has been mentioned. Moreover, this scenario also constitutes a real case study for MapReduce, since one of its most common practical applications. Here, why this has been enlightened and highlighted here, because you need to segregate. Suppose you are getting a very large file. Most of the times what happens, if you are working with a mobile company, mobile transaction data will come in streams. You need to divide those files into smaller size files, because it comes in gigabyte. You will not be having time to even do this job. Are you getting my point? Dividing the file into pieces, and you need to record from where to where you have divided. You need to create a log file. You need to create an index file for that also, so that you should not get a wrong analysis. Okay, so you need to properly cut and record the location from where you have taken the data to create a new file, and what is the end record for that file. So if you do it properly, then only you can send that file to the MapReduce for analysis. But in this case, in Aneka, it creates up to 10 MB. It creates a file. It means it is the job of the Aneka platform only to create pieces of files, and then these pieces of files can be taken for analysis. That's why they are taking. So it's very easy to do Aneka MapReduce implementation, because it is helping you to analyze the data, because the data is in proper format. So next is a driver program implementation. In the driver program, this class sets up MapReduce job and configure it with the log parsing mapper as well as the log parsing reducer, which we have discussed previously. It also configures the MapReduce runtime in order, sets the appropriate format for input and output files. Okay, so this is the file which does the driver program, which runs these programs, because running the application is also very important. How to run the program, and you need to have a track of the programs which are running, because multiple programs are running for the same data, whether the data has been completed, whether some executor failed execution in the middle only, maybe because of some catastrophic failures. All these need to be handled. Maybe you need to create a situation where some errors are generated, and those errors are need to be handled properly. The ecosystem of execution should be properly done, and you should have a proper analysis of execution also, because how many file chunks have been sent, how many file chunks have been received, is there any problem with any of the executor? If there is a problem with some executor, the same code, the data need to be taken to another executor, where that executor has completed its execution. All these need to be done. So lot of intricacy is there in running the application. That's very important. So you can see the pie chart for this in a moment. Okay, so here is again another continuation of the driver program. Okay, it is calling the function look at it, logger.start is there. So main, so why try and catch is called here. Look at it, there is a exception handling also, because I was just mentioning there may be some errors where some program, some executor who could not execute the program in proper time, maybe you need to take it. Because of that, the entire process should not be collapsed. So you need to handle this properly. So that's why you need to catch some exceptions. Suppose you are having some error, you need to report that error, and you need to do proper remedial action for that, and then finally you need to stop the logger. So in the main program, it is something like, no, it's calling the mapper function is a parsing mapper as well as parsing reducer, and for multiple data and then for multiple executors, you need to handle, you need to coordinate the execution, and then finally, if there is no problem, then you can stop it. Otherwise, if there is a problem, you report the error, and then you can take suitable action for that. Okay, so here is a configuration initialization to initialize a mapper, and then you need to start a MapReduce executor here, MapReduce add. So you are adding it to the group. Okay, and then these are all, so group add, group filter, format. Okay, and these are some of the properties which we have just discussed. The multiple properties are available in the implementation. Those have been added here to keep track of the data. So the format, the filter, the new line, the separator have been added here. So undone, which I was mentioning. So after completing the job, there must be some garbage collector or the completer who completes the execution must be there. So undone, the program, the function which does the job of garbage collection and clearing of all the data and verifying whether it has executed completely, properly, without any error. So if E exception is not equal to null, then there is some error reported. Otherwise, it has executed successfully. The successful job, log parsing job terminated successfully, and that should be done. So here, all garbage collection outputs can be generated. Okay, you can see this program where it is writing the file from the intermediate files. It is writing the entire file into a single file where the output is generated. Okay, so this tells you that from the multiple results, results will be extracted and it will be written onto single file, and that is the final output. Okay, this is how it is done. If there is a problem here, also you are doing try catch, it's exception handling. If there is some problem where you can't write a file into the data into the file, then you may need to exit that, and you should say that there is some problem. Otherwise, you need to mention that the statistics saved to some file. So here log level.txt and component.txt, because these are all the simple data which has been generated. There is no need to store these values into the database management system. You need to create only simple text file. So texts are generated, log level text as well as component level text are generated. Okay, and then these are the things which there is. If you have a report error, there is a parsing error, there is a execution error, then you need to print that. So there is a report error which we have used in the previous slide. Report error is the function which has been developed. Shown. Okay, this is one file we need to know, the configuration file, because we already have understood that there must be some configuration need to be done before actual execution. So always you understand, because the configuration need to be sent to the similar configuration should be there in all the distributed file system where MapReduce functions are executed. So they need to have a configuration file. How the configuration file comes, because in your mobile phone, when you get a configuration file for your internet, it comes in an XML format. Here also it is similar to that. It has been shown that user file transfer is false, single submission auto polling the time is 1000, like that. This is a standard specification which is given to all the users, all the executors. So here is a scheduler location where the scheduler is available, localhost 9090, that is the port number at which your scheduler can be connected. So here is using a TCP connection. It's a sort of a telnet connection which will be done through from your system. So TCP is there, it's not HTTP, you can verify like FTP. There's a TCP connection at 9090, it is connected to Aneka. So like that, this is the configuration file, from where you need to get the file, from where you need to which location you need to send the file, all that is mentioned here. So execution log is there, look at it, the output group name is output, and it is the format, it is text, and this file will be generated. So the example, whatever you have discussed, it has been shown here. Please look at it. The execution which I have just now explained has been written here. The execution of test, the distributed infrastructure has been used to consisting of several workers nodes, one master node, interconnection through the LAN. We processed 18 log files with the 122 MB size, aggregated total of 120 MB size. The execution of MapReduce of collected data produced the result that are stored in the log level.txt and components.txt. This is the output of the file. The do graphs shown. Let me show that graph now. In particular, 60% of log content is skipped during the classification. Look at it. So 60% is skipped. The content is more likely due to the result of stack traces dumps into the log file, which produces a result error or wants entities in a sequence line that are not recognized. So here we have not recognized. I was telling you the same thing here. So error and warning entities also can be configured. Right? You need to analyze how many errors have been generated, how many warning messages have come. Also can be done. In this program, they have taken only the log level as well as component level extraction and segregation. That's why these are not taken. So it's a sort of keyword matching where natural language processing, if you apply a particular key is there, key value is there, and you are extracting that. So here, let me go to the log level entity. See here, debug error, info, skipped, and warning. See warning, there was no warning in the file. See, it depends on the log file. You need not worry about this much, because skipped 62%, they have not taken for any analysis. Info, they have taken 22%, debug, they have taken 12%, and errors, there are 4% of errors have taken. So the skipped area is dependent on the data which you are giving. Otherwise, all data will not be skipped, because they are extracting particularly how many. For example, it is something like, we can get the web log. Maybe in your web programming laboratory, you write a program that how many users have logged in, how many users have visited our web page. The counter you are generating. So there are some counter programs where it will record from which IP address which has come. So based on the IP address, you can analyze from which country it has come. From how many, from US people have tried to access our website, from England, how many people have tried to access, from India, how many people have tried to access, can also be done through this MapReduce implementation. So in that case, everything will be verified. There is no skipped data, because everything is your log file where your first page of your website is being accessed. So please go through that gec.ac.in. Currently, how many users have tried to access, and then you can analyze that. How many people from which location they have tried to access that web page can also be done. So it's similar to this program which I was explaining. Okay, next here they have shown another picture, component entities distribution. That is, you can look at the picture here, and also the number of entries available. So 189,000 entries are there for algorithm base. Okay, 76,895 is there for skipped. Okay, and look at it. This is where you are doing it. No, you can simply take your mastering cloud computing textbook as the data, because it's a file PDF is available. You can analyze how many cloud words have been used, how many times the cloud word has been used in this book. Can also be a simple program. You can also try executing that. Those who are interested, you can write a simple MapReduce program and you can analyze your output. Okay, this is what the distribution among the discussion which has been made there has been shown in this slide. Please go through that. Thank you very much for patient listening.
Thank you, sir.